Hello, algebra students and math curiosos. I'm here today to give you a short little lesson on operations with radicals and roots, a subject we've been doing for a while now. What we're going to look at today is the mathematical operations of addition and subtraction of roots. And the question is, can we add these? Can we add or subtract radicals, first off? So my addition symbol I'm going to use is just a plus sign, and short, instead of writing subtraction, I'm going to go ahead and use the minus sign. Can we add, subtract roots? And if so, how do we do that, right? So if so, how? And then which properties do we use? And so what we know is we can add these. Yes. If so the idea is, yes, we could add these if the radicands are the same. And what we do is we just simplify radicals and add, subtract if same. They're the same root. Okay. So those are the basics that we are looking at here. So we can add radicals. We'll add them like terms, just like we know how to add and subtract like terms. Well, the same holds with roots. The roots just have to be exactly the same, and whatever is underneath the radical has to be exactly the same. So the main rule is, as long as the nth root in the radicand, this value is the same for terms after you simplify, if you need to. Okay, so after you simplify if you need to, you can add, subtract, just as if doing like terms. I don't want to say like terms because that's a little bit of a confusing statement. So here's our basic, the pattern or the properties to use would be if I had the nth root of a plus the nth root of a. I have one of these and another one of these that's exactly the same. That means I have two of these. Okay, so that's my rule of addition here. In a nutshell, my rule of subtraction in a nutshell would be, okay, if I have the nth root of some real number a, and I'm going to subtract the nth root of some number a, well, I have one of these, and I take one of these away, that means I have 0 nth roots of a, which is just a 0. Okay, and that would be my answer. So that's a basic property of radicals. So let's go ahead and apply some problems. And of course, we're going to apply it when we have coefficients. So you will have numbers out in front. So if I had a 2 here, and this is just 1, that would become 2 of these plus 1 of these, which is 3. So we'll use some concrete examples to get you started, and we'll try to keep this video short. All right. And then move on to another one on multiplication and division. So this is how this works. And typical examples with adding and subtracting radicals will say, simplify again. Simplify. Some books, homework problems to say simplify. Some will say simplify if possible, because sometimes we just can't add or subtract. Okay, so let's go ahead and start with a problem. Number 1, let's say we had the square root of 3 plus 2 square root of 3. Okay, we want to simplify this. Well, first step you want to look at is is the radical that you're using as simple as possible. So the first step is, are the radicals, I'll have to write this in blue, my red's not working very well. Yes, go to step 2, right? If no, simplify. You always want to make sure these are as simple as possible. Okay, number 2, look for any like terms. Look at all the index numbers. So there's an understood 2 here. Look at the index number. Look at the radicand and the radicand. And that means if they're exactly identical, these parts are exactly identical, we could add them. So what we want to do next is add or subtract the like, I'll call them like radicals. And like radicals means that the index and number and radicand are identical. Okay, so I'm going to go to the next step. I see that this and this, these are alike. So I'm going to rewrite this because a lot of people forget that there's one of these here. So if we go ahead and write in what the coefficient is, we put our 1 there, we have one of these square roots of 3's plus 2 of these square roots of 3's will give us 3 square root of 3. Okay, and that's our final answer here. So that works out. Okay, 2, I'm going to do an example where we have, let's say, 4 square root of 3x plus 8 square root of 3x. So in this case, again, we have our radicands. These are exactly identical. I have 4 of these and 8 of these. So I end up with 4 plus 2, which is 12 square roots of 3x. Wonderful. Okay. Now, what if I had, in part 3, what if I had the square root of 3x squared plus 2 square root of 2x square root of 3. Okay, these don't look like they're the same here, do they? Okay. So what I will have to do is, I'm going to have to, this to me looks fishy because I see that I have an x squared under x, so I want to simplify this first. Okay, so in this case, I'm going to rewrite this as square root of 3 times x squared, where I'm going to pull out the x squared out front, and that becomes x, plus 2x square root of 3. Okay, now this becomes x. So the square root of x squared, when that comes out, is x square root of 3 plus 2x square root of 3. Now how do I add these? Well, the x is just like what we did with like terms before, right? We have an x to the first power, x to the first power. Those parts are like. What about the radicals? These parts are like as well. So this entire, we have one of these and we have two of these. So what we have to do is say this and this, these are like. So these are like terms. Everything's exactly the same. The exponent, the x, the index number of the radical, and the radicand part. So I add one of these and two of these will make 3x square root of 3. Bingo. Okay? And we know that subtraction works exactly the same thing. It's just another way of adding, but with negatives. Okay, so let's go ahead and do a few more here. And like with anything in math, the proficiency comes with lots and lots of practice. There's such a good variety of problems out there. So hence, always do your text work, worksheets, look for other problems to do. There's plenty of algebra books out there to keep the world busy for millennia. So anyways, let's go ahead and take a look at another problem here. This is 4. Pay attention to my ordering. And let's go ahead and simplify something like this. 4x square root of x plus 8 square root of x. Can you do this one? Okay, well, let's look. Is that as simple as possible? That is simplified. So this is simplified. Already. Okay, what about these parts? Well, there's nothing else we could do here. Here, what's something strange is that this is our part that lets us know everything behind the coefficient is the part that tells us whether we could add or subtract these. So in this case, we can't do this because these are not like. So these are not like, cannot basically add. So some problems just don't say simplify, they'll say add or subtract. So you cannot add and or simplify. So your answer is just as it is. Okay, sometimes you're just stuck with radicals you can't do anything about. Okay, so let's go ahead and take a look at another problem like what about the square root of 5 minus the square root of 45? Let's practice with some of our minuses. How do we do this? Well, let's see. This is simplified. This isn't. So I'm going to go ahead and rewrite this as the square root of 5 minus the square root of 9 times 5. And this becomes the square root of 5. And we might have some luck in this case in simplification. This comes out and gives you a 3 square root of 5. And now I have 1 square root of 5 minus 3 square roots of 5 gives me a negative 2 square roots of 5. So you will end up with negative numbers sometimes as well. Okay, let's see. Let's try some other combinations here. Let's do some cube roots now. All right. Let's do a problem like like this. This is a little bit of a jump. Okay, so we have quite a few steps involved. Possibly, we don't really know that for sure, but we want to, our first goal is always look at these parts and say, oh, can we make these easier? Can we make these easier? Okay, so next, let's take a look. Let's see. Let's rewrite this one by the simplification rules we know. So we'll rewrite this as 27 times 2 times x. And I'll rewrite this next part as, let's have a little more room here, minus, we don't want to get that minus mixed up as being underneath there, 7 cube root of 2 times x to the 6 times x. Correct? Does everything look good? Do these add up using your rules of exponents to the originals? Yes, they do. So our next step would be to say, okay, we have 3, and this piece right here comes out and gives you, when you take the cube root of 27, we're looking at what perfect cube makes 27, so 3 times 3 times 3 gives you that, so that becomes a 3 the moment it jumps out. And here, this is the other root that we have, the cube root of x to the 6 gives you x squared, because 6 divided by 3 is x squared, so we get x squared out of this. Okay, so rewriting this, we get 3, and then we're left with 3 times what this becomes outside, 3 times 3 by our rules of multiplication, and then times the cube root of 2x. Now I'm going to put this part a little down here, so I give myself a little good space, and this becomes minus 7 times the x squared times the cube root of 2x. Is that correct? Okay, yeah, looks like this works. Okay, so it looks like I got my radicals simplified. Next step is I'm just going to clean this up a little bit. This becomes 9, the cube root of 2x, minus 7x squared, cube root of 2x. All right, can I subtract these? My 2 over here a little bit more. Can I subtract these? Well, absolutely not. Okay, because it looks like it, the radicals are the same. I want to make sure I emphasize that the x is underneath the radical. These parts are exactly the same, right, the radicals, but this one also has an x squared out in front, so they're not like terms. You can't go further. So this is where students usually tend to make a mistake from my experience, is that they'll want to go far and invent new rules. You've got to know when to stop. There's that old saying, when the horse is dead, get off, right? Don't make something else out of this. Know when to stop. So that's where we would stop in this case. Okay, let's see what we need to adjust here to make this work. Well, in order to make this work, I would need an x squared here. So maybe if we put one in here, let's do one more problem here. 2. I'm going to leave that one up for comparison. So if we do a problem where it will work, such as 3 cube root of 54x cubed minus 7 cube root of 2x to the 7th, not an x cubed, I think we're going to need an x to the 7th here, right? That's right, because we're dealing with a cube root. So we're going to need to have these parts the same here, or at least have an x out in front. So other variations are I can already have an x squared out in front to make this work, etc. I could have an x to the 4th here. So there's several combinations that will make this work. So abiding by the same rules, we'd say 3 times the cube root of 27 times 2 times x to the 6 times x to the 1st, where this part comes out and this part comes out, minus 7 and the cube root of 2 times x to the 6 times x, the 1st. Okay. And what we get in this case is we have 3 minus 7, which is minus, I'm jumping the gun here, First we have to realize that this comes out, we got to simplify these radicals. So I'm still simplifying radicals first. Sort of went into robot mode there. Okay, so 3 times, this becomes 3, and x to the 6 divided by 3 becomes x squared, and this becomes times cube root of 2x. All right, minus 7, and this becomes times x to the 6 divided by 3 is x squared times the cube root of 2x. Okay, let's see what we have here now. Simplifying my coefficient out in front, I have 9x squared cube root of 2x minus 7x squared cube root of 2x. Okay, so here, now I see that I've made a problem in which these two radicands are alike, but also the rest of the problem is like. These are exactly the same, which is what I need in order to apply the rules of addition, subtraction. And this final answer becomes, I could combine these, squish these together, and get 2x squared cube root of 2x all together. Okay, so that is how that one works. And just double checking. With those examples, I think you're in good shape to be able to tackle most of the radical problems. We're going to see more of these come up with multiplication division, which will be our next topic. So this is M.Kaul signing off, and I hope this helped you through simplifying more radicals. All right, thank you.